Good morning, good afternoon, and good evening. It's the Oracle of Chinemkutu, and welcome back. In the previous presentation of question 2, which we named the application of calculus 6 differentiation part 1, 2.1 and 2.2, we found out that the graph of fx given here is x minus 2 squared multiplied by x minus a, which we named equation 1. We found out that a is equal to minus 3, and therefore we got fx is equal to x minus 2 squared multiplied by x plus 3, and we named that equation 3. So in this part of the presentation, we are continuing with part 2 of the same question, and we are hoping that we can do both 2.3 and 2.4 in this part, and they have only 2 videos to this question. So 2.3 says determine the coordinates of C, and 2.4 says for which values of x will f be concave down. So starting with 2.3, knowing that fx is equal to x minus 2 squared multiplied by x plus 3, we need to find the coordinates of C, and as you have been given here, we were told that C is a turning point of f. That's C there. And what that means is that the gradient at that point is actually equal to 0. And once one can get the gradient of a curve by differentiating the curve once, so you get the first derivative. And that is the reason why this question is actually 5 marks, because that's where the application to differentiation happens. And so for us to be able to differentiate this curve simply to get the first derivative, let us expand fx and write it as a cubic function. So 2.3, first expand f of x and present it as a cubic function. So in order to expand f of x is equal to y is equal to, first we expand the binomial factor, which is x minus 2 to the power 2, and the expansion of binomial factors is really very simple. X minus 2 to the power 2, you say x times x equals to x squared, and then you say x times minus 2 is minus 2x times 2, that gives us minus 4x, and finally you say minus 2 times minus 2, that gives you plus 4. This saves you time in an examination. You don't have to write x minus 2 bracket multiplied by x minus 2 and then you multiply item by item. It will consume your time. So we have the binomial factor expanded. We just multiply it out by x plus 3. So it will be x squared. So therefore y is equal to x squared times x, that gives us x to the power 3, x squared times 3, that gives us plus 3 to the x to the power 2, then minus 4x times x, that gives us minus 4x to the power 2, and 4x times 3, that gives us minus 12x, then plus 4 times x, that gives us plus 4x, and 4 times 3, that gives us plus 12. Then we can say y is equal to x cubed plus 3x squared minus 4x gives us minus x squared, and minus 12x plus 4x gives us minus 8x plus 12. So to get the turning point coordinates, we are looking at C. We equate the first derivative to 0. Therefore, the gradient of f of x at any point is given by the first derivative. Therefore, f prime x is equal to dy dx is equal to, we differentiate that expression there, that gives us 3x squared minus 2x minus 8. This is 12, not 2. And the constant goes to 0 when we differentiate it. So then this we can call our equation 4. So then we say 3x squared minus 2x minus 8 is equal to 0 at C. That is point C. Then for us to get the value of x there, we factorize. So here we can say 3x, and here we can say x, and two values of 8, that would give us 8, and also would give us a difference of 2 after multiplying by 3. If we have the 2, 4 and 2, so if we can have 4 there, 2 there, because we have got a minus there, we should have a minus here, because it will be 3x times minus 2 gives you minus 6 plus 4x, that will give you minus 2. So this one would be a minus and this one would be a plus. And this is how we work out the factorization quickly. And then that way you make sure that 4 times minus 2 gives you minus 8. 4x times minus 6x gives you minus 2x, and 3x times x gives you 3x squared. And our factorization is done. So if we say this part is equal to 0, so then we can say 3x plus 4 is equal to 0, or x minus 2 is equal to 0, and therefore we have 3x is equal to minus 4 and x is equal to minus 4 over 3, or x is equal to 2. And the x cannot be equal to 2 there, it should be negative, and therefore our solution is x is equal to minus 4 over 3, and the x coordinate of C is minus 4 over 3. To get the y, coordinate, we substitute the value of x into equation 3. So then we will have y is equal to minus 4 over 3 minus 2 squared multiplied by minus 4 over 3 plus 3 over 1. This we can put as 2 over 1. Then we have y is equal to bracket, if we put 3 as our common denominator, then we have 3 into 3, 1 times minus 4, gives us minus 4, 1 into 3 is 3 times minus 2, gives us minus 6 to the power 2, bracket, if we say our common denominator is 3 into 3, 1, that gives us minus 4. 1 into 3 is 3 plus 9. So we are running out of space. We can rub the top part so that we can continue with our working. And we also create space for doing 2.4. So then from here, going at the top, we can say y is equal to minus 10 over 3 squared multiplied by minus 4 plus 9 is 5 over 3, and this is equal to 100 over 9 times 5 over 3, which is equal to 500 over 27. So therefore, the coordinates of C are minus 4 over 3 and 500 over 27. And then we understand why this question is 5 marks. So we can rub that, and that gives us the coordinates of C, and our computation is done. So we need to do 2.4. So to do 2.4, we still need the expansion of that the equation of f of x. So we have y is equal to x squared minus 4x plus 4 and the x plus 3, which gives us x cubed plus 3x squared minus 4x squared minus 12x plus 4x plus 12, and y is equal to x cubed minus x squared minus 8x plus 12, and previously we had shown that dy dx is equal to 3x minus 2x minus 8, and 12 goes to 0. So question 2.4 says, for which values of x will f be concave down? So if a function is concave down at an interval, the second derivative of that function is less than 0 at that interval. So in essence, when you look at a graph, the function is concave at all areas where the line of the gradient on the curve lies on top of the curve. So that means if the line can be drawn on top of the curve, you know that that part of the curve is concave down. And when the gradient of the line can be drawn underneath the curve, then you know that at that interval the curve is concave up, and this is very simple to illustrate. But however, to know the intervals on which the concavity is said to be down, you need to find the second derivative of the function, and then you say that second derivative is less, and you calculate for which values is less than 0, and you calculate for which values of x for which the second derivative is less than 0. So from our previous question 2.3, we said that this is our equation 4, and then from 4, d2y dx2, which is the second derivative, we differentiate dy dx is equal to, this is 3x squared. You should be worried about these mistakes where you do a differential and you forget to write the power. Then the next step of your calculation becomes a problem. So always have the presence of mind to be sure that you are following through, and if you notice any mistakes of that sort, correct them. So here we now differentiate again. So this gives us 2 times 3, 6, x to the power 2 minus 1 is 1. So this is 6x minus 2. And the differential of a constant is 0. So therefore we say the graph of f of x is concave down when 6x minus 2 is less than 0. That is, the second derivative is less than 0. So this becomes a simple inequality, and if we divide by 2 both sides, we get 3x minus 1 is less than 0. And minus 1 goes to the right hand side, it becomes a positive. So we have 3x is less than 1, and therefore x is less than 1 over 3. So from the point where x is 1 over 3, that point not included, going to the left of that point, the graph will be concave down. So if we say that this point is 2, which we found to be 2 twice, and then we say this point is 1, so somewhere there